Hi there, I'm Alan Hong, Strategic Marketing Manager here at Jurassic Technologies. Today, I will be showing you how to set up your SOPC and how to configure Nios 2. We'll be analyzing how to create a system from the System Builder software, choosing a specific memory to store instructions on, and more. So here, I have an Altera DE2-115, designed and manufactured here at Jurassic. It's powered by a Cyclone 4 FPGA. Our goal today is quite simple. Set up our SOPC and Nios 2 in order to blink an LED. For this tutorial, I will be using version 9.1 of Quartus 2 and Nios 2. I should also mention that I will speed up certain parts of this video for viewing purposes, such as compilation and building projects. So now let's get started with our design. We'll navigate over to our DE2-115 folder. And now we can see that we have our Tools folder. We'll go over to our System Builder folder and execute our System Builder software. The System Builder software is a GUI to create your system very simply by just naming your project file and selecting the components that you would like to use. We'll start out by naming it my first Nios 2. And since we're only going to be blinking LEDs in this design, we'll only need our clock, LEDs, and we'll be using flash for later. So now that we're done with that, we can generate our file. We'll go back to our desktop and create a new folder called my first Nios 2 and save it there. Now going back to our desktop, we can see that our folder, my first Nios 2, we can see that it includes our System Builder generated files. And we'll open up our project file to enter into Quartus 2. So here we have our top level module. We can see here that this code is generated by Jurassic System Builder. And all of our components have already been declared for us and organized into parameter declarations, port declarations, red wire declarations, and structural coding. And if we all go over to the Assignments menu and open up our assignment editor, we can see that our pins have already been assigned for us, making it very simple to get started. So now all we have to do is to open up our SOPC builder and create our system. So now going into our SOPC builder, we can create our new system and we'll name our system DE2-115 SOPC. And our target language will be Verilog. And so the first thing we want to do is to create our Nios 2 processor. Now you can see that Nios 2 is separated into 3 different kinds. We'll be choosing the F version for this design. And we'll click on Finish. And over here you can see the SOPC automatically appends an _0, but we don't want that. We want to create very simple names, so we'll rename that to CPU. Next we want to create our communication interface, and we'll choose JTAG UR. For this one, we'll accept the default values. Click on Finish. And we'll also rename this one JTAG UR. And third, we want to create our memory for our Nios 2 instruction set. So we'll be choosing our on-chip memory. Over here we'll choose RAM for our instruction set memory. The only thing we're going to be changing here is our total memory size, which we'll be changing to 204,800. Click on Finish. And same with this one, we'll rename this, get rid of that annoying 0 at the end. And we'll go back to our CPU. And over here we can see that we have a reset vector and an exception vector, and we'll point this towards our on-chip memory. We'll click Finish. And lastly, we're going to add our LEDs. So we'll go to Peripherals, Microcontroller Peripherals, and PIOs, which stands for Parallel Input Output. For this one, we'll just have 8 and output ports only because we're using LEDs. We'll click on Finish. For this one, we'll rename it to PIO_LED. So we have all of our components. We still have 2 warnings here because of our base addresses. So all we have to do here is to click on Auto Assign Base Addresses from our System menu. And we get rid of the warnings. So all this is done, we can click on Generate, Save, and the generation will take a few minutes. So system generation was successful, and we can exit now. So now we're back to our top level module. We can go to Open, scroll down to our DE2115 SOPC, which is the main file. And as we go down, actually let me just click on Find DE2115 SOPC. We can see here, this is the main module we're going to be working with. So we'll just copy this over to my first Nios 2, and we'll paste it down at structural coding. Get rid of the module here. Use 0, we'll be naming this module, and also assigning the input and output pins. So for clock 0, we're going to be using our clock 50. And putting it in. For reset, since it's negative edge, it's active low, we'll be writing a high bit to our reset. An output port from our PIO LED. We'll be using our LED green LEDs, so LEDG. So we'll click on Save, and now we can compile our project. This will take a few minutes. And our full compilation was successful. So after compilation is complete, we want to program what we already compiled into our DE2 board. So we go to Programmer, and over here it should be USB Blaster, and we want to program/configure our SOF into our DE2. So we click on Start. Okay, now it's done programming. If you look over to our DE2 board right now, you can see that our DE2 board LEDs are not blinking because we still need to have the Nios 2 instructions loaded into the Nios 2. So now let's start up our Nios 2 IDE. The first thing we'll see is this Altera Nios 2 IDE welcome screen. And the first thing we're going to do is we're going to go to Workspace in the File menu. We're going to switch our workspace to our target destination. If we scroll down, we can see my first Nios 2. And in this folder, we want to create a separate folder called Software. Click OK. And we'll go over to our workbench right now. So now we're on the correct workspace. We can go to File, click on New, and we'll click on Nios 2 C/C++ application. Over here we have our Hello World 0, and that's what we're going to start out with. So we'll specify our location, software, and we'll also browse to our PTF file, which was generated when we compiled. So our CPU is our CPU, which we specified in SOPC Builder. And we'll first pull up an example project that is already prepared for us. And so we have our project here. First we want to do is build our project. So we go to Hello World, this folder right here. This is our main folder. And this is the system library for our D2115, which was automatically generated. So we go to our source folder and we right-click on the folder, go down until we see Build Project, and we click on that. This might take a few minutes.